Hello and welcome back to the channel. So today we're going to be going over the first 10 problems of this year's AMC 8. I'm going to leave a link in the description to all the problems and solutions on the Art of Problem Solving website if you want to try and solve these for yourself. I would highly recommend taking this test before watching this, even if you're preparing for, say, next year's test. So, let's just get right into it. This is the first video of a three-part series. Today we'll be doing problems 1 through 10, then we'll do 11 through 20 in the next video, and then in the final video we'll do 21 through 25. So 1 through 10 are the easiest, and then, the problems get harder as their number goes up. So, problem 1 reads, Luca is making lemonade to sell at a school fundraiser. His recipe requires 4 times as much water as sugar and twice as much sugar as lemon juice. He uses 3 cups of lemon juice. How much water does he need? So the first step in all of these problems is always to look at what are we solving for. Now we are solving for the cup of water. How many cups of water does he need? We look and we see he needs 4 times as much water as sugar. So now we have to look at, well, how much sugar does he need? He needs twice as much sugar as lemon juice. So we can just go backwards. How much lemon juice does he need? He needs 3 cups of lemon juice. So since he needs twice as much sugar as lemon juice, we can do 3 times 2 is 6, which is 6 cups of sugar. Of sugar. And then let's look how much times as much sugar as water. I don't know what I'm saying. You guys get what I'm saying. So he has 6 cups of sugar, and then we multiply that by 4, because he needs 4 times as much water as sugar, and then we get 24 cups, and that is the correct answer for this problem. So that's that. The correct answer is E24. Next, problem 2. So it reads, Four friends do yard work for their neighbors over the weekend, earning $15, $20, $25, and $40 respectively. They decide to split their earnings equally among themselves. In total, how much will the friend who earned $40 give to the others? So first, we have to see that these guys are splitting their money equally. What that means is we need to find the average of these 4 numbers. So we have to look at how much money each of them are getting. So we can do this by finding the mean. You should probably know how to find the mean, which is 15 plus 20 plus 25 plus 40, and then we'll divide that by how many numbers, which in this case is 4. So when we add this up, we get 100, and then we can divide that by 4. 100 divided by 4 equals 25. And next, what we have to do is, let's look at what the question is asking. In total, how much will the friend who earned $40 give to the others? So the friend that earned $40, he's going to end up with 25. So this is very simple. We just subtract 40 minus 25 to see how much he's giving, which is 15. And so the correct answer is C, $15. Also, please let me know in the comments if you're ever confused about anything. I'll try to respond to all the comments, or at least the comments with questions and stuff. Okay, next, problem 3. Carrie has a rectangular garden that measures 6 feet by 8 feet. She plants the entire garden with strawberry plants. Carrie is able to plant 4 strawberry plants per square foot, and she harvests an average of 10 strawberries per plant. How many strawberries can she expect to harvest? Now this problem is pretty similar to problem 1, where we have an initial value and we have to multiply it by another number, which is kind of like a middle value, and then multiply that by another number to get our answer. So first let's look at what we are solving for. How many strawberries can she expect to harvest? Well, we have 10 strawberries per plant, so how many plants? 4 plants per square foot. So how many feet? Well, we can look at it, and 6 feet times 8 feet equals 48 square feet. So this is the area of her garden. Next, we look and we see that it says 4 plants per square foot. So we have 48 square feet, so we can multiply 48 times 4, which equals 192. And finally, we see that she has 10 strawberries per plant. So 192 times 10 equals 1,920. So that's 1,920, which means the correct answer is D. Next, 3 hexagons of increasing size are shown below. Suppose the dot pattern continues so that each successive hexagon contains one more band of dots. How many dots are in the next hexagon? Now, we can look at each hexagon and we can see that the first hexagon has 1 dot, as we can see. The second hexagon has has 7 dots, and then the next hexagon has 19 dots. So we can look at a pattern. These are all about finding patterns for these kinds of problems. So we look and we see, okay, what's 7 minus 1? 6. What's 19 minus 7? 12. So I don't know if you guys can see the pattern, but we are increasing by multiples of 6. So we have 1 then to 7, so that's an increase of 6, and then 7 to 19, which is an increase of 12. So that means the next band of dots will have an increase of 18. So we have 19 in this row plus 18 equals 37. So that's the answer to problem 4. Now, this problem is a bit harder to teach because it's just all about finding patterns, and it's sometimes difficult because it's hard to spot these patterns. I actually took this test, and it took me a few minutes to find the pattern, actually. This problem took me a little longer than I would have liked, but I ended up finding the pattern at the end. Next, problem 5. 3/4 of a pitcher is filled with pineapple juice. The pitcher is emptied by pouring an equal amount of juice into each of 5 cups. What percent of the total capacity of the pitcher did each cup receive? So here we have each cup is filled with three quarters of a pitcher, is filled with juice. And we see that the pitcher is then emptied into each of 5 cups. So this is just simple multiplication. So we have 3/4 of the pitcher. So always write out your numbers when you're looking at a problem. So 3/4 of a pitcher, and then we have to divide that into 5 cups. So 3/4 divided by 5, which we know we have to do the reciprocal, so we can do 3/4 times 1/5 equals 3/20. And so next we can say, what percent of the total capacity of the pitcher did each cup receive? Well, we know that each cup is receiving 3/20 of the pitcher, which we can just convert that to over 100, because we know that percents are out of 100. So 3 times 20, we can see that 20 is a multiple of 100, so we do 20 times 5. And so also 3 times 5, so we get 15 out of 100, which means that it is 15% of the total capacity of the pitcher. Next, Aaron, Darren, Karen, Marin, and Sharon, rode on a small train that has 5 cars that seat 1 person each. Marin sat in the last car, Aaron sat directly behind Sharon. Darren sat in one of the cars in front of Aaron. At least 1 person sat between Karen and Darren. Who sat in the middle car? Okay, so we can create, I'm just going to put 5 different lines here for the 5 different spots. So that's spot 1, spot 2, spot 3, spot 4, spot 5. So the first thing is very easy. It says Marin sat in the last car. So we can put Marin there. Also, it's very important to keep in mind what the question is asking for. Who sat in the middle car? Okay, so let's, I'm going to put A, D, K, M, and S for each person. So next we can look at the next part of the problem. Adam sat directly behind Sharon. So now we have three different possibilities. We have the possibility that Aaron is here and Sharon is here, that Aaron is here and Sharon is here, and Aaron is in the second seat and Sharon is in the front seat. So we don't know anything about where Aaron and Sharon are except that Aaron is directly behind her. But we don't know in which seat they're going to be. So we see it says, Darren sat in one of the cars in front of Aaron. So that will rule out the possibility that Sharon is here and Aaron is in the second seat, because Darren would have to be in front of them, which would not leave enough space. I know this problem is tough to explain, and I know you probably are getting very confused right now. But next, we can move on to the next sentence, which says, at least one person sat between Karen and Darren. So that means that Aaron will not be able to sit in the back, like right here, because if he sat here, then Sharon would have to sit here, but that leaves Darren and Karen sitting next to each other. So what we realize is that the correct answer is that Darren will have to sit in the front. And since we've ruled out the two possibilities of Aaron sitting here and Aaron sitting here, then we know that Aaron has to be in the middle. And we can solve out the rest of the problem, but we already know that all we're asking for is who sat in the middle car, which is Aaron, A. But, you know, we already technically solved the rest of the problem where Karen sits here and Sharon sits here. So, that's it for that problem. On to problem 7. Whoa, sorry about that. Okay. How many integers between 20 and 2,400 have 4 distinct digits arranged in increasing order? So we can see, so first we have to observe that the second digit of the number cannot be 1 or 2, because that would be equal to the first digit. So we can look at the example in case you're confused. And we know that the number has to be between 2,400 and 2,020, but we know it's not, the hundreds digit is not 1 or 2, which means that it's going to be in the 2,300s only. Okay, the next thing we can do is the second digit cannot be 4, because it has to be less than 2,400. We already went over that. So it must be 3. It remains to the later two digits, which must be from 4, 5, 6, 7, 8, and 9. Now we can use the choose function, which is that function where, if you don't know what that is, it kind of looks like this, where you have two parentheses and you have, say, a number here. In this case, it's going to be 6 choose 2. And then, so it's like this, where there's no fraction line. And 6 choose 2 equals 15, equals 6 times 5, which you kind of multiply the number previous. So 6 times 5 over 2 times 1. And that's going to equal 30 over 2, which is 15. So that means that the correct answer is 15. And the reason that there's 6 choose 2 is because there's two digits that we're choosing, the 10s and the 1s digit, and there's 6 possibilities, 4, 5, 6, 7, 8, and 9. So the correct answer is 15 when we do 6 choose 2. Okay, on to the next problem. Ricardo has 2,020 coins, some of which are pennies, and the rest of which are nickels. He has at least 1 penny and at least 1 nickel. What are the differences in cents between the greatest possible and least possible amounts of money that Ricardo can have? Okay, so we can look at this and see. Let's find the least amount of money that he can get first. So we can do that he has 2019 pennies, right? We know that he has 2020 coins. So obviously to find the least amount of money, he's going to have 2019 pennies and a 1 nickel. And to find the most amount, he's going to have 2019 nickels and 1 penny. And this is obviously just because he has to have at least 1 penny and 1 nickel. So what we can do here is we can have we can write out here 2019 times 1 is 2019. I don't know why I wrote that. Plus 5 equals 2024. Now next we have 5 times 2019, which is, I believe, 10,095. Now this is the very bit of a long way, I guess you could call it, but it's the easiest to understand. Equals 10,095. All you're gonna have to do is end up doing, like, I don't know, 30 seconds of multiplication, and then plus our 1 equals 10,096 because we have that extra penny at the end. So then we can do a 10,096 minus 2024 equals 8,072 is what I meant. Okay. And, well, would you look at that? That is option C, and so that is the correct answer, because you remember is asking what is the difference in cents between the greatest possible, but the main word is difference. Okay, on to problem 9, the second to last problem of today, and from what I've seen, people actually struggled with this one for some reason, a bit more than usual, and you kind of just have to be careful. So, there are a few ways to do this problem. It reads, Akasha's birthday cake is in the form of a 4x4 by 4 inch cube. The cake has icing on the top and the 4 side faces and no icing on the bottom. Suppose the cake is cut into 64 smaller cubes, as we can see in the picture, each measuring 1 by 1 by 1 inch, as shown below. And how many of the small pieces will the icing have exactly 2 sides? So we see that for each small cube, which does not form part of the bottom face, so excluding these ones in the bottom row, it will have exactly 2 faces with icing only if it is one of the 2 center cubes on the edge of a larger cube. Now that was exactly from the website. What they're basically saying is these cubes here, these few cubes, this cube and this cube, they will have 2. Obviously these corner cubes won't because they have 1, 2, 3 faces. So we can count first all of these cubes, the ones that I have circles in. So we can count those. So 1, 2, 3, 4, 5, 6, 7, 8, and then we can count the ones on the side too. 9, 10, 11, 12, 13, 14, 15, 16. We have to count the one in the back corner that you can't see. So that is 16 cubes. Now, we could stop there at C16, but that's not the answer. A lot of people just stop there, but they forgot about the cubes on the bottom. Now, they said there's nothing on this bottom face, so under these, there's nothing. But these corner cubes here have 2 faces with icing. So that's 2 cubes, the cube in the back left and the cube in the back right on the bottom. And that's 4 more cubes, so the answer is 20. Because we have 16 from cubes like these, and then 4 more from the cubes in the bottom corners. So that's that, and on to the final problem of the day, problem 10. Now, this problem is a bit tough, and I know a lot of people who did it the long way, which is not an issue if you're lost, but you should never do this the long way. So we can count it, but let's just read the problem first. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a Steely, and a tiger. She wants to display them in a row on a shelf, but she doesn't want to put the Steely and the tiger next to one another. In how many ways can she do this? Okay, so as we can see here, it's problem 10. So the amount of possibilities that we can do it. So the most important thing first is to find how many possible ways, with no constraints, can we organize these 4 marbles. So we have 4 factorial equals 24, which is, as you know, 4 times 3 times 2 times 1 equals 24. So that's how many possible ways, without any constraints, that we can count these marbles. So now we look at the constraint, which she does not want to put the Steely and Tiger next to each other. So in order to count that, we can treat them kind of together as like a super marble. There are 2 ways to arrange the Steely and the Tiger within the super marble. We can call them that when they're next to each other. So there are 2 ways to arrange the Steely and Tiger within the super marble. So then 3 factorial 6 ways to put the super marble in a row with the Aggie and the bumblebee. So we know that 3 factorial is 6. So then we do, the answer is 24 minus 2, since there's 2 ways to arrange this Steely and Tiger. Steely first, Tiger second, Tiger first, Steely second. And then, so that means 24 minus 2 times 6, which is 3 factorial, equals 12. So the answer is C, 12. Now, a lot of people prefer to do it just normal counting it out, which is not really a problem, but it just takes a really long time. And please let me know if you're confused about anything in the comments down below, and I'll see you guys in the next one. Peace.